Welcome back to a brand new episode of LLM News, where I cover the most exciting and most important developments around large language models and AI. Before proceeding, please consider leaving a like and subscribe to the channel. That really helps the channel a lot and will allow us to keep doing these episodes in the future. So we had a very exciting week of announcements around AI. The first big one is from Black Forest Labs. So this is a new company that was built by researchers and engineers who have worked on projects like VQGAN, latent diffusion, stable diffusion, more notably, stable diffusion XL, and so on. This set of researchers and engineers do have an outstanding track record. So they're making available a wide range of models, and they're also announcing their Series Seed funding round of $31 million, with their main investor being Andreessen Horowitz, and including notable participation from other angel investors as mentioned here. What they have announced here is this family of models called FLUX, and this is their first version. And you can see how FLUX has different models like Pro version, the Dev version, and they have another version called Schnell. So you can see the performance of this compared to something like Stable Diffusion 3 Ultra or DALI and so on. And they mention why they have released different variants. So they have the Pro, which is their best model, can be accessed via APIs already using something like Replicate or Fall.ai. They also have the Dev version for it, which is an open weight guidance distilled model for non-commercial applications. And they also have the Schnell, which is their fastest model. I guess this is a smaller model of the three that you can use and available on Hugging Face. And also you can find the inference code on GitHub. This is more about the comparison with the creative capabilities in respect to cost. So you can see that Pro is the one that has the most capabilities, but it's the most costly one. The Dev version falls in the middle here. And obviously this one is the cheaper one. And the capabilities, you see how it increases. And you can see here how good this particular model is. So the quality is pretty impressive. They have different aspect ratios and resolutions in 0.1 and 2.0 megapixels. That's really amazing. You can see the 2.0 megapixels here. And one thing that was interesting from this announcement is that they're also working, and this one is an upcoming suite of competitive generative text-to-video systems. And if you click on that link, you will see that they have this example here. I wonder if this example is just for marketing or actually generated by their new text-to-video generative model that's coming soon. And this is going to make it really, really exciting in the space because now we have more players in text-to-video. We've had companies like Runway, OpenAI, and so it will be really interesting to see how competitive the space gets and what's the angle, what's the differentiation that they are providing. That will be interesting to see. Next up, we have this announcement from Google DeepMind. They made available Gemini 1.5 Pro recently. This is the experimental 0801. So this was the 1st of August. They announced this model and it was tested already on the chatbot arena. So they have garnered over 12K community votes. And we can see that Google Gemini has claimed the #1 spot with a score of 1,300. You will see it right here, how it's on top of GPT-4o and Cloud 3.5. So this is a very capable model. If you're interested in learning more about these models and its capabilities, we took it for a test in the Google AI Studio. So I will link the video in the description box. I'm very impressed by the extraction capabilities in particular, like how to extract information from images and PDFs. And it definitely feels like it has good vision capabilities, like what GPT-4o has. And it also has good code generation and PDF understanding and reasoning capabilities, like what I have experienced with Cloud 3.5 Sonnet. Google DeepMind also announced Gemma 2b, which outperforms already GPT 3.5 and Llama 2 70b. So this is a small model, and this is a trend that I'm seeing, right? So the smaller models are catching up really fast with the bigger models, and apparently they're using some kind of distillation here. So it's interesting the capabilities that these smaller models have and how they match in terms of performance with the bigger models. There's more information about this on their blog, but I've actually done a summary of this also on my YouTube. If you're interested in that, I'll highlight it. Something that was really interesting from this announcement, which is what a lot of companies are doing today, is the release also of verifiers and safety tools, along with some other tools to better understand how these models actually work internally. They have opened a bunch of sparse autoencoders, which can be used as tools to better understand how this model understands instructions and what features are activated when you prompt it a certain way, what features correspond to certain tokens and so on, given that context you're providing in the prompt. So that's, I think, is an interesting way to analyze these models to better understand how to better steer them and how to make them safer, and even how to make them more performant at the particular task that you're interested in. Next up, we have this paper, Meta Rewarding LLMs. So the idea is really simple. And what they propose in this paper, what's novel, is they use another component, which is a judge that judges the judgment itself. So it's a bit like a separate role that's doing a sort of meta judging to evaluate the model's own judgments. And by doing this, they can improve how good the model is at performing specific tasks. So they have tested this on the Alpaca eval benchmark and Arena Hard benchmark, and you can see the improvements here that I'm highlighting here. With this particular model, the Llama 3.8 being struck. So that's interesting that they chose this model too, to apply this particular method. I'm not sure how scalable this method in particular is, like how it applies to bigger models, but it'd be interesting to see and apply this idea to bigger models to see what's the improvement in performance. That's the thing that I'm interested in. I like this idea of self-improvement because you bypass the need for using humans to judge the quality of outputs, which is something that a lot of companies are working on today. And this seems to be a method that does this in an automatic way. When I read the paper, they mentioned that in order to improve the quality of the outputs of the model, it's really important to have some kind of judging component. Another interesting paper was this one from Baidu. They present an end-to-end self-reasoning framework to improve the reliability and traceability of RAG systems. Essentially, what they're proposing here is a three-step process where they're leveraging self-reasoning to improve the overall performance of the RAG system itself. And they have some performance here that they have documented, and they say that their framework achieves comparable performance to GPT-4 with only 2K training samples generated by GPT-4 itself. So there are a couple of papers actually that present very similar ideas, but I like this idea because it breaks the problem into different parts. They first need to make the model more aware of the relevance, right, of those documents compared to the question, which is the first step. Then the other one is more about the evidence, which is important for generating more trustworthy and reliable responses. And then they have also this trajectory, which kind of puts everything together and comes up with the final inferred answer. Next up, I just wanted to highlight this paper. I thought it was interesting. I think this is a very simple method. It's called constrained chain of thought, which limits the model reasoning output length without sacrificing performance. As we know, whenever you're asking it, if you ask it to generate a chain of thought steps, it usually tends to lead to more reliable responses and improves the accuracy overall. But what they're proposing here is that with chain of thought, what you get is something that can take up a lot of latency, can be very costly as well. So how to make it more cost efficient? And what they're proposing is that they have this prompt, this Constrained-CoT, that not only improves accuracy, but also reduces the output length by 28 words. So this is what they have gotten with their results on the GSM-8K, which is a math word problem solving benchmark. So very simple approach. I think by just adding, let's think a bit step by step and limit the answer length to 45 words. Now, all I can say is I don't know how reliable this is. I know that conciseness is something that a lot of companies are working on with these models because these models tend to be super verbose in their responses. And a lot of business use cases, you want to make sure that the models or the system that you're using based on these language models is as cost efficient as possible. So the idea of limiting the size of the outputs or the length of the output is actually something that has been applied since the beginning of large language models. But to combine this idea with chain of thought, I think is really interesting. I don't know, again, as I said, how reliable this is because when you say 45 words, usually these models don't get exactly 45 words or they don't understand the concept of 45 words. But I think you can get some approximation with this, right? And you can say something like 2 sentences, 3 sentences, 4 sentences, and still the model will try to get these sentences and make that output more concise as possible, which your application might need and can benefit from. Next up, we had this LLM Hallucination Index RAG special for 2024. And this one is about basically testing a bunch of closed source and open source large language models on several RAG tasks. So what they're testing for is how good the model is at responding accurately and factually to whatever context was passed in the RAG system itself. So they're testing for short context, medium context, long context. I did a video about this if you're interested, where I go into more detail and analyze some of the results and insights they have documented here. And it's an interesting one because they talk about how to do the evaluation, what metrics to use, right? How do you know when a model is hallucinating or not? They even provide examples where the model is hallucinating. So that's really cool. They also highlight a few trends. Now, in summary, their trends are open source is closing the gap. Context length is also something that's really useful, but we have seen that with longer context length, these models are not as efficient and as effective on certain tasks. Like we lose actually the accuracy of the particular language model. We have seen some improvements as well, where these longer context LLMs are getting more and more accurate. And larger is not always better. As we know, these smaller models are also becoming more effective and efficient at a variety of tasks. So a Gemma 2B model would be a good example of that. And then Anthropic outperforms OpenAI. This is something that's debated. Something that I came across a few days ago is this announcement from LangChain, which is the LangGraph Studio. This they refer to as the first agent IDE. For you all have been building agents, you would know that the way you build agents, you would use something like Crew AI or even like LangChain or even like Llama Index as well to build these agents. But something that would be useful is to have a sort of IDE or some visual way of interacting with this system that you're building and testing and evaluating, right, on different prompts and different scenarios that you may have. And so this is what they are doing with LangGraph. I think visualizing and interacting with like complex agentic workflows is an interesting direction. I don't know how successful this would be, but I think this is something that we will be experimenting with in the coming days and potentially even be doing a video as well. So I've been building a few agentic workflows, but the way I've done this is basically just using code. I really haven't had the need to visualize certain components. I do see that visualizing the process of an agentic workflow could be an interesting way of improving the system and experimenting and evaluating how good the performance is of certain parts of the overall agentic workflow. So I think it could be interesting from that point of view. Next up, we have this announcement from Character.ai proposing this idea of prompt design, essentially building out tools, and they're open sourcing these tools as well. And what they mention here is really interesting, that it's basically a transition from prompt engineering to prompt design. We focus mostly on the design, like designing templates, right? And this allows us to scale and make things more user-centric. So this is very favorable for developers and also for folks that are non-technical as well. So there's a lot of ideas that they're proposing in this post. I suggest everyone that's working on LLMs to do check out this blog post. I'm not going to go through all the details, but something that caught my attention is this idea of prompt templates, which is not a new idea, but it's something that a lot of tools like LangChain do promote. And it's something that we as developers use a lot. And so I like that they mentioned that here. And there's a lot of really good examples here to sort of understand the concept. They are focusing on building a library that allows you to work and design better prompts. So for instance, in this example, you will see that there are certain properties of the prompts that may be interesting to inspect. Prompt portability is really an interesting area as well. If you are working in collaboration, you may want to have templates that you can share amongst your teams. So I like that they're attempting this as well. The idea of supporting function calling as well, here's a good example of that. The whole idea is that they believe that this is a leap forward, like shifting the focus from manual string manipulations, which is essentially what prompt engineering is, to something that's more streamlined and intuitive and it's more design focused, right? It's more user centric, and you scale the effort of designing prompts. Next up, we have this release from PyTorch. So PyTorch releases its own LLM solution called torchchat. There's a lot of examples out there and a lot of tools that are used to be able to create like chat systems with these LLMs. And torchchat is one more example of this. And they're open sourcing this. It even includes a UI to chat with the LLMs on the browser, certain LLMs like Mistral, the Llama models, and so on. And they support like running models on desktop server and on mobile as well. So the cool thing about this is that it's actually a native PyTorch library, unlike other libraries that you may see around, which means they have all those optimizations already that they can leverage and that they can tap into. They also have integrations with like the Hugging Face Hub and the models. And it even has an evaluation feature as well that you can use. And lastly, I wanted to highlight this exceptional visual guide to quantization. So Martin wrote this really interesting guide that basically shows you in a visual form what this idea of quantization is. In short, the quantization involves methods to compressing large language models to make them more accessible. How do you leverage these bigger models? You will need quantized versions of those. So it's an interesting concept, actually a very important concept for LLM developers today and AI engineers. I think going forward, a lot of the LLM providers will be using some form of quantization. So I think as a developer, it'll be good to get very familiar with this concept. And I think Martin has done an exceptional job at explaining what quantization is, in my opinion. He goes through an introduction to it, right? What's the post-training quantization, quantization that we're training, different methods that are used as well, right? And the common data types, for instance, will be good to know. I think this is the best guide that I've seen to quantization yet. There are a couple of research papers and survey papers, but it doesn't even come close. That will be it for this episode of LLM News. Thanks again for watching and for staying tuned, and I'll see you all on the next one.